Okay, so in 4-3, you had to prove what to show me that two triangles were congruent. You had to prove what? To show two triangles were congruent.
That all the sides and angles were congruent.
All the sides and all the angles were the same, right? Yes. Can I get some participation and like the headphones out of the ears? Thank you. Okay, so come on. Headphones out the ears. Come on, thank you. Okay, so I needed you to learn that in case you forget what's coming in the second half of chapter 4. So if you forget chapter 4 stuff, the end of it, you can always fall back on the fact that if all three angles are the same and all three sides are the same, then they're congruent. However, there are 5 shortcuts. If in a triangle, if all the sides are the same, without even looking at the angles, they're congruent. So this side, this side, this side. So like CA, if it's congruent to this one, and this is congruent to this, and this is congruent to this, just by looking at the sides, you can say they're congruent because the side theorem tells us that they are. If you have side, angle, side, now you have to go in order. So it can't just be 2 random sides and an angle. That angle has to be sandwiched between the 2 sides. So for example, side, angle, side, side, angle, side. So if you have SAS, then they're congruent. If you have, take off your pen, ASA, angle, side, angle, you see how it's the same ones. They're in order. Angle, side, angle. It's not like it's angle, side, angle. They have to be in exact order. Then they're the same. So we're only doing these 3 today. We're going to do these 2 tomorrow. However, these are a lot of S's and A's, right? Right? Lots of S's, lots of A's. If you ever write a dirty word, you've done something wrong. Okay? Dirty word never works. So don't use it as an excuse to write it on your paper. Okay? So there's a song that goes with this to help you memorize it. And it goes like this. SSS, SAS, ASA works too. AAS or hypotenuse leg, but the donkey way won't do. Get it?
I get it. Ah!
You don't get it? The donkey way. Don't, no one say it. No one.
Yeah.
Okay, so it's literally in order. SSS, SAS, ASA works too. AAS or hypotenuse leg, but the donkey way won't do. Okay? Can y'all try with me? Okay, like literally read it in order. Ready? SSS, SAS, ASA works too. AAS or hypotenuse leg, but the donkey way won't do. Hey. Oh, and another way that never works, the donkey way never works. Backwards or forwards. Get me? Backwards or forwards. It never works. Okay? So,
Teacher students, excuse interruption. At this time, I need all students who are participating in the computer science field trip to UAB to report to the bus canopy at this time. Students going on the UAB field trip for computer science, please report to the bus canopy at this time.
okay, so there's 3 that will never work. Donkey backwards, spelled backwards. Donkey spelled forwards. Or angle, angle, angle. AAA never works either. Okay? So those 3. So let's talk about the 3 that do work. Side, side, side. This is probably the easiest one to use. So if CB has 1 dash, then it's congruent to QS, which has another dash. So those both have 1 dash. Okay? Well, then AC has 2, and QR has 2. And then AB has 3, and RS has 3. So because you know AB is congruent to RS, QS is congruent to the yellow, purple is congruent to purple, because you know SSS, these 2 triangles are congruent by side, side, side. Okay? Side, angle, side it has to be sandwiched. So DF has 1 dash. So it's congruent to TA that has 1 dash. Then the angle in between the two sides that are congruent is congruent. So angle F is congruent to angle A, and then FE is congruent to CA. Because they are in this order, side, angle, side, side, angle, side, then you can say these two triangles are congruent by SAS. So you might be told to write the congruency statement. So you could say triangle DFE is congruent to, how would I name this triangle? TAC. Go back and write a congruency statement for this one. Emily, what did your first one say? What's the order of your first triangle over here? Yeah, like this triangle. How would you name it? Okay, ACB. Okay, so you said ACB. So if you use the order ACB, then that's 2, 1, 3. So this one would have to be in RQS, right? Okay. So side, 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 angle, side. Now we have angle, side, angle. Same thing, except for instead of an angle being sandwiched by two sides, we have a side being sandwiched by two angles. So angle W is congruent to angle F. This side is congruent to this side. And then this angle O is congruent to V. Angle, side, angle, angle, side, angle. Therefore, we know that, Jack, what would you put this first one? What's the order that you would use? TOW. Toe is congruent to, so he went T to, no dashes and rainbows to 2 to 1. So I'd have to go no to 2 to 1. So it would be EVF. Okay, so below is just practice. So that's all the information you need for this section. We're going to do AAS and hypotenuse leg tomorrow. So your choices are only these 3. Oh, I got to put a little thing here. Okay, so in all of these problems, you can only use the first 3. If it is true, write a congruent statement. However, it can be not possible. You could not have enough information. If you don't have enough information, write not possible. So let's try 1. Now remember, in 4.3, we had to use what we knew, like from the past chapters. So is there something here we could say we know?
Yes.
Yes, so DG does bisect, and here's how we know. Because it tells me 2 dashes, 2 dashes. If it doesn't tell you that it bisects or the dashes aren't there, then you don't know. But in this case we do, and we know this is reflexive. So let's just start with what we know. How many sides do you know?
2, 3.
3, including this one, right? Reflexive. So we know that this side is congruent to this side, congruent, congruent, and then reflexive. So which one of these 3 could we use? SSS, side, side, side. So I need you to write 2 things. First, write SSS. So by the SSS congruence theorem, triangle what is congruent to triangle what? FGD and EGD. Okay. FGD, EGD. Try 2. If it helps, go through, you color-coordinated people, and you can make all of your different things in different colors, if it helps you. Well, what do you know? How many sides do you know? 2, and is the angle sandwiched? Are they both in the same position on both triangles? So, which theorem would you use, Isabel? SAS, good. Because you have side, your angle sandwiched. SAS. And then you could say triangle. Isabel, what triangle would you put first? X, W, Z is congruent. So she started in the middle, went to 1, and then that way. So let's start in the middle, go to 1, and then this way. So it would be triangle ETY. Y'all kind of see how this is working? Okay, let's look at number 3. I know TS is congruent to what side? AB. I know SR is congruent to BC. And then I know angle R is congruent to angle C. Well, if we wrote this out, it would not be pretty, right?
Right.
Think of the order. Side, side, angle. Is that backwards or forwards the donkey way?
Yes.
Yes. So it does not work. So in this case, it is not possible. Because you cannot use that shortcut. Okay, 4. Is there something we can add on?
Vertical.
Vertical. And since you know that's vertical, and you know H is congruent to M, can't we use third angle theorem too, just to see if it will help us? We might not use it, but we can assume it, right? Well, I don't know all the sides, so side is out. I only know one side, so side angle side is out. But do I know an angle, a side, and then another angle? An angle, a side, and then another angle, right? So we can use ASA, because you know angle, side, angle. Angle, side, angle. Are y'all kind of seeing it?
Yes.
Okay, so triangle, tell me, she's not here either. Erin, tell me what you would have put as the first triangle. HKL, so triangle HKL is congruent to triangle 1 to 3, so MJL. Okay, I want to skip to 8, and then I'm going to let you try 5 through 7, and the rest of them. But do you see how triangle 8 is kind of overlapping? If this is hard for you to see, sometimes it's hard for me to envision because they're overlapped. You can draw 2 separate triangles. So here's T, there was a dash, here's N, here's O, this was a rainbow. Then on the other side, see how I'm just kind of separating them? P dash O, no, yeah, P O N. And then I knew this rainbow. But what did I know about ON? Is ON a part of both triangles? Yes. So by what theorem can I say that they're congruent? What, you're getting one step ahead of me. I meant, like, what theorem can I say that ON is congruent to ON?
Angle, sides.
Reflexive. Because this ON is a segment of both triangles, we can put a dash and a dash. Now, some of you may be able to look at this and see it. Sometimes it's hard for me to see because it's on top of each other. So, which theorem would you use? Side angle side. Good. So, triangle TNO is congruent to triangle PTNO, PON, right? PON? Okay, on 9 through 12, where it tells you some things that are happening. You know in your proofs where you would mark what's happening? You could, like, you don't have to prove it yet. We aren't writing proofs yet. It's coming. But you can label this. So AC bisects angle BAD. Well, I know that means that these two are congruent, right? So you can write what's happening. Okay, I want you to do 5 through 12, and then we'll go over it together. So I want you to try 9 through 12.